A CD-ROM, Cd-Rom, is a pre-pressed optical compact disc which contains data. The name is an acronym which stands for Compact Disc Read-Only Memory. Computers can read CD-ROMs, but cannot write to CD-ROMs which are not writable or erasable. Until the mid-2000s, CD-ROMs were popularly used to distribute software for computers and video game consoles. Some CDs, called enhanced CDs, hold both computer data and audio, with the latter capable of being played on a CD player, while data is only usable on a computer. The Yellow Book is the technical standard that defines the format of CD-ROMs. One of a set of color-bound books that contain the technical specifications for all CD formats. The Yellow Book, created by Sony and Philips in 1988. Was the first extension of compact disc digital audio. It adapted the format to hold any form of digital data. CD-ROM discs. Media CD-ROMs are identical in appearance to audio CDs, and data are stored and retrieved in a very similar manner. Discs are made from a 1.2 mm thick disc of polycarbonate plastic, with a thin layer of aluminium to make a reflective surface. The most common size of CD-ROM is 120 mm in diameter, though the smaller mini-CD standard with an 80 mm diameter, as well as shaped compact discs in numerous non-standard sizes and molds, are also available. Data are stored on the disc as a series of microscopic indentations. A laser is shone onto the reflective surface of the disc to read the pattern of pits and lands. Because the depth of the pits is approximately 1/4 to 1/6 of the wavelength of the laser light used to read the disc, the reflected beam's phase is shifted in relation to the incoming beam, causing destructive interference and reducing the reflected beam's intensity. This pattern of changing intensity of the reflected beam is converted into binary data. Standard several formats are used for data stored on compact discs, known as the Rainbow Books. The Yellow Book, published in 1988, defines the specifications for CD-ROMs, standardized in 1989 as the ISO, IEC 10149, ECMA 130 standard. The CD-ROM standard builds on top of the original Red Book CD-DAS standard for CD audio. Other standards, such as the White Book for video CDs, further define formats based on the CD-ROM specifications. The Yellow Book itself is not freely available, but the standards with the corresponding content can be downloaded for free from ISO or ECMA. There are several separate standards that define how to structure data files on a CD-ROM. ISO 9660 defines the standard file system for a CD-ROM. ISO 13490 is an improvement on this standard, which adds support for non-sequential write-once and rewritable disks such as CDR and CDRW, as well as multiple sessions. The ISO 13346 standard was designed to address most of the shortcomings of ISO 9660, and a subset of it evolved into the UDF format, which was adopted for DVDs. The bootable CD specification, to make a CD emulate a hard disk or floppy disk, is called El Torito. CD-ROM format data stored on CD-ROMs follows the standard CD data encoding techniques described in the Red Book specification. This includes cross-interleaved Reed-Solomon coding, 8-to-14 modulation, and the use of pits and lands for coding the bits into the physical surface of the CD. The structures used to group data on a CD-ROM are also derived from the Red Book. Like audio CDs, a CD-ROM sector contains 2,352 bytes of user data, composed of 98 frames, each consisting of 33 bytes. Unlike audio CDs, the data stored in these sectors corresponds to any type of digital data, not audio samples encoded according to the audio CD specification. To structure, address and protect this data, the CD-ROM standard further defines two sector modes, Mode 1 and Mode 2, which describe two different layouts for the data inside a sector. A track inside a CD-ROM only contains sectors in the same mode, but if multiple tracks are present in a CD-ROM, each track can have its sectors in a different mode from the rest of the tracks. They can also coexist with audio CD tracks as well, which is the case of mixed-mode CDs. Both Mode 1 and 2 sectors use the first 16 bytes for header information, but differ in the remaining 2,336 bytes due to the use of error correction bytes. Unlike an audio CD, a CD-ROM cannot rely on error concealment by interpolation. A higher reliability of the retrieved data is required. To achieve improved error correction and detection, Mode 1, used mostly for digital data, adds a 32-bit cyclic redundancy check code for error detection, and a third layer of Reed-Solomon error correction using a Reed-Solomon product-like code. Mode 1 therefore contains 288 bytes per sector for error detection and correction, leaving 2,048 bytes per sector available for data. Mode 2, which is more appropriate for image or video data, contains no additional error detection or correction bytes, having therefore 2,336 available data bytes per sector. Note that both modes, like audio CDs, still benefit from the lower layers of error correction at the frame level, before being stored on a disk with the techniques described above. Each CD-ROM sector is scrambled to prevent some problematic patterns from showing up. These scrambled sectors then follow the same encoding process described in the Red Book in order to be finally stored on a CD. The following table shows a comparison of the structure of sectors in CD-DAR and CD-ROMs. The net byte rate of a Mode 1 CD-ROM, based on comparison to CD-DAR audio standards, is 44,100 Hz times 16 bits, sample times 2 channels times 2048, 2352/8 equals 153.6 kilobytes per second equals. This value is defined as 1 times speed. Therefore, for Mode 1 CD-ROMs, a 1-time Cd-Rom drive reads 150 halves equals 75 consecutive sectors per second. The playing time of a standard CD is 74 minutes, or 4,440 seconds, contained in 333,000 blocks or sectors. Therefore, the net capacity of a Mode 1 CD-ROM is 682 megabytes or, equivalently, for 80-minute CDs, the capacity is 737 megabytes. CD-ROM XA extension. CD-ROM XA is an extension of the Yellow Book standard for CD-ROMs that combines compressed audio, video, and computer data, allowing all to be accessed simultaneously. It was intended as a bridge between CD-ROM and CDI and was published by Sony and Philips in 1991. XA stands for Extended Architecture. CD-ROM XA defines two new sector layouts, called Mode 2 Form 1 and Mode 2 Form 2. XA Mode 2 Form 1 is similar to the Mode 1 structure described above, and can interleave with XA Mode 2 Form 2 sectors. It is used for data. XA Mode 2 Form 2 has 2,324 bytes of user data, and is similar to the standard Mode 2 but with error detection bytes added. It can interleave with XA Mode 2 Form 1 sectors, and it is used for audio, video data. Video CDs, Super Video CDs, Photo CDs, Enhanced Music CDs and CDI use these sector modes. The following table shows a comparison of the structure of sectors in CD-ROM XA modes. Disk images. When a disk image of a CD-ROM is created, this can be done in either RAW mode, or obtaining only the sector's useful data. The file size of a disk image created in RAW mode is always a multiple of 2,352 bytes. Disk image formats that store raw CD-ROM sectors include CCD, IMG, Q, bin, and MDS, MDF. The size of a disk image created from the data in the sectors will depend on the type of sectors it is using. For example, if a CD-ROM Mode 1 image is created by extracting only each sector's data, its size will be a multiple of 2048. This is usually the case for ISO disk images. On a 74-minute CDR, it is possible to fit larger disk images using RAW mode, up to 333,000 times 2,352 equals 783,216,000 bytes. This is the upper limit for raw images created on a 74-min or Redbook CD. The 14.8% increase is due to the discarding of error correction data. Manufacture pre-pressed CD-ROMs are mass-produced by a process of stamping where a glass master disc is created and used to make stampers, which are in turn used to manufacture multiple copies of the final disc with the pits already present. Recordable and rewritable discs are manufactured by a different method, whereby the data are recorded on them by a laser changing the properties of a dye or phase transition material in a process that is often referred to as burning. Capacity CD-ROM capacities are normally expressed with binary prefixes, subtracting the space used for error correction data. A standard 120 mm 700 MB CD-ROM can actually hold about 737 MB of data with error correction. In comparison, a single-layer DVD-ROM can hold 4.7 GB of error-protected data, more than 6 CD-ROMs. Cd-Rom drives. Cd-Rom disks are read using Cd-Rom drives. A Cd-Rom drive may be connected to the computer via an IDE, SCSI, SATA, FireWire, or USB interface or a proprietary interface, such as the Panasonic CD interface, LMSI, Philips, Sony and Mitsumi standards. Virtually all modern CD-ROM drives can also play audio CDs when used with the right software. Laser and optics CD-ROM drives employ a near-infrared 780 nanometers laser diode. Transfer rate CD-ROM drives are rated with a speed factor relative to music CDs. If a CD-ROM is read at the same rotational speed as an audio CD, the data transfer rate is commonly called 1 times. At this data rate, the track moves along under the laser spot at about 1.2 meters per second. To maintain this linear velocity as the optical head moves to different positions, the angular velocity is varied from 500 revolutions per minute at the inner edge to 200 revolutions per minute at the outer edge. The 1 times speed rating for CD-ROM is different from the 1 times speed rating for DVDs. By increasing the speed at which the disc is spun, data can be transferred at greater rates. For example, a CD-ROM drive that can read at 8 times speed spins the disc at 1600 to 4000 revolutions per minute, giving a linear velocity of 9.6 meters per second and a transfer rate of above 12 times speed. Most drives read at constant angular velocity so that the motor is not made to change from one speed to another as the head seeks from place to place on the disc. In CAV mode, the times number denotes the transfer rate at the outer edge of the disc, where it is a maximum. 20 times was thought to be the maximum speed due to mechanical constraints until Samsung Electronics introduced the -3230 Seychelles rupees, a 32x CD-ROM drive which uses a ball-bearing system to balance the spinning disc and the drive to reduce vibration and noise. As of 2004, the fastest transfer rate commonly available is about 52 times or 10,400 revolutions per minute, and higher spin speeds are limited by the strength of the polycarbonate plastic of which the discs are made. At 52 times, the linear velocity of the outermost part of the disc is around 65 meters per second. However, improvements can still be obtained using multiple laser pickups, as demonstrated by the Kenwood Truex 72 times, which uses 7 laser beams and a rotation speed of approximately 10 times. Faster 12 times drives were common beginning in early 1997. Above 12 times speed, there are problems with vibration and heat. CAV drives give speeds up to 30 times at the outer edge of the disk with the same rotational speed as a standard constant linear velocity 12 times, or 32 times with a slight increase. However, due to the nature of CAV, the actual throughput increase is less than 30/12. In fact, roughly 20 times average for a completely full disk, and even less for a partially filled one. Problems with vibration, owing to limits on achievable symmetry and strength in mass-produced media, mean that CD-ROM drive speeds have not massively increased since the late 1990s. Over 10 years later, commonly available drives vary between 24 times and 52 times, all using CAV to achieve their claimed max speeds, with 32 times through 48 times most common. Even so, these speeds can cause poor reading and even shattering of poorly made or physically damaged media, with small cracks rapidly growing into catastrophic breakages when centripetally stressed at 10,000 to 13,000 revolutions per minute. High rotational speeds also produce undesirable noise from disk vibration, rushing air in the spindle motor itself. Most 21st-century drives allow 4 slow-speed modes for the sake of safety, accurate reading or silence, and will automatically fall back if a large number of sequential read errors and retries are encountered. Other methods of improving read speed were trialed, such as using multiple optical beams, increasing throughput up to 72 times with a 10 times spin speed, but along with other technologies like 90 to 99-minute recordable media and double-density recorders. Their utility was nullified by the introduction of consumer DVD-ROM drives capable of consistent 36 times CD-ROM speeds or higher. Additionally, with a 700 MB CD-ROM fully readable in under 2.5 minutes at 52 times CAV, increases in actual data transfer rate are decreasingly influential on overall effective drive speed when taken into consideration with other factors, such as loading, unloading, media recognition, spin up, down and random seek times, making for much decreased returns on development investment. A similar stratification effect has since been seen in DVD development, where maximum speed has stabilized at 16 times CAV and capacity at 4.3 in, with higher speed and capacity needs instead being catered to by Blu-ray drives. CD recordable drives are often sold with 3 different speed ratings, 1 speed for write-once operations, 1 for rewrite operations, and 1 for read-only operations. The speeds are typically listed in that order, i.e., a 12 times, 10 times, 32 times CD drive can, CPU and media permitting, write to CDR disks at 12 times speed, write to CDRW disks at 10 times speed, and read from CDs at 32 times speed. Copyright issues. Software distributors, and in particular distributors of computer games, often make use of various copy protection schemes to prevent software running from any media besides the original CD-ROMs. This differs somewhat from audio CD protection in that it is usually implemented in both the media and the software itself. The CD-ROM itself may contain weak sectors to make copying the disk more difficult, and additional data that may be difficult or impossible to copy to a CDR or disk image, but which the software checks for each time it is run to ensure an original disk and not an unauthorized copy is present in the computer's CD-ROM drive. Manufacturers of CD writers are encouraged by the music industry to ensure that every drive they produce has a unique identifier, which will be encoded by the drive on every disc that it records. The RID or Recorder Identification Code This is a counterpart to the source identification code, an 8-character code beginning with IFPI that is usually stamped on discs produced by CD recording plants.